Okay, so we're looking at circuits this week. So we're going to go over a few pages of your notes today. And so you're going to just follow along with me. Remember, you can pause this video at any time. And you're going to fill this out along with me. So we're only going to do slides 2, 3, and 4 today. So we're going to review basic circuits, and then we're going to start looking at parallel and series circuits. So remember that a basic circuit is just a closed path. Remember, that's the important part, is the path has to be closed in order for electricity to flow. And so we call a circuit a closed path through which electricity flows. And the word circuit looks a lot like the word circle, because a circle is also a closed path. And if you look at a circuit, you'll notice it's kind of a circular shape. For a circuit to work, it has to be a complete path, meaning there cannot be any breaks. So we have the sample circuit down here. You notice it's one full, complete path. I could trace it with my pencil. And there are no breaks or gaps in the circuit. So I follow my wire. My wire is able to go, my current is able to flow through the light bulb because the light bulb is cased in a conductive material. And then it flows back into the battery and over again. And so that current, that closed path is what allows our light bulb to light up. And if you do have a switch, which remember, you do not have to have a switch, but if you do have a switch, the switch must be closed in order for your light bulb to light. If the lights are on, that would mean that the circuit is closed. If the lights are off, that must mean that the circuit is open. So if the light turns off, that tells you that there is no electricity flowing, and that's happening because there's a gap somewhere in the circuit. Either you have a break, or maybe you have a switch that's open. All right, let's review conductors and insulators quickly. A conductor, we're going to keep it very short. A conductor allows the flow of energy. And remember, you can always zoom in. If you can't see, you've got your little zoom icon right here if you need to. So I'll zoom in just a little bit. Okay, so conductors allow the flow. And for examples, we're just going to put all metals. We're just going to keep it simple. All metals are conductors. Insulators stop the flow of energy. And examples would be, we'll just say nonmetals. So rubbers, plastics, cardboard, wood, stone, glass, all of these things are insulators. All of these things would stop the flow of energy. All right, and then we're going to look at basic circuits. So we're just going to drag these check marks to show what we have to have. And so we're looking at only what circuits absolutely have to have. Okay, so nothing extra for this checklist. So circuits have to have a conductor, of course, because you have to have something that will allow the electricity to be conducted, to flow. And so we're going to drag a check over to conductor. You have to have a bulb or a buzzer. So you just have to have something that can take that electrical energy and transform it into something that we can actually see or hear, something that we can detect. You have to have a battery because that's your power source. Now, a switch, a lot of circuits have switches, and you will see a lot of switches in your circuits, but it's important that you understand that you do not have to have a switch. So we're not going to put a check there. And an insulator, we are going to go ahead and call this a necessity because you need insulators to be able to protect you from getting shocked. So all circuits in real life are going to be cased in by an insulator, an insulative coating, like wires that are coated in rubber or plastic, so that when you touch the wire, you don't get electrocuted because your body is actually a conductor of electricity. So if you were to wrap your hands around an exposed wire, that electrical current would be conducted by you, it would flow into your body. So you need an insulator between you and the electricity to protect you. Okay, slide 3. So we looked at basic circuits. This is just a very basic circuit, but in 5th grade, you have to be able to look at more complicated circuits. So some things that we look at are parallel and series circuits, and these are circuits that have more than one light bulb lit up, or more than one light bulb included in the circuit. So a parallel circuit is a circuit in which the current is split. So instead of following one path, like in a basic circuit, instead of following just one path over and over again, in a parallel circuit, there are multiple paths. And so the electric current can split and run through all of those separate pathways. And because of this, because you have different pathways, when one light goes out, the others are actually able to stay lit. And we will look more at that this week. So I'm going to show you how to use, so you have the components here, and everything is set up for you to be able to draw wires in and have this be a parallel circuit. So I'm going to show you how to do that. So if you look at your instructions, you have a scribble line tool that you're going to use. So that is up here. So you're going to click on this line tool. And you're actually going to not click on the line. You're going to click on the arrow right next to it. And then you're going to come down here and click scribble. Okay, so I'm going to draw the wires to make this a parallel circuit. So I want you to go ahead and just watch first, and then you can do it on your paper. So I'm using the scribble tool, and to use the scribble tool, I'm just going to click when I'm ready to start. So I've clicked, and now, going to click and hold down, and I'm basically just drawing the wire to where I want it to go. I'm going to go ahead and bring it all the way around. So through the switch, through the light bulb, and back to the battery. And when you're done, then you can unclick and it will let go and keep your wire there. And then you just click off to make it stay. So this is my first pathway. So this looks a lot like just a basic circuit. I start at the battery. I'm able to make a complete path. I have a closed switch, goes through the light bulb and back to the battery. So my light bulb is able to light. But because this is a parallel circuit that I'm setting up, I have multiple components, or I have multiple light bulbs. And so I'm going to give each light bulb its own path. So I'm going to get my scribble tool again. Always start at your battery. So I'm just going to click and hold it down to draw. Going through my switch. Now I'm going to go through this second light bulb. Come back down, and then I'm going to join up with that first path to get back to the battery. And then you click, and then it lets go. So now I have two pathways. Same power source, but the electrical current is traveling and being split where the wires split, where the path splits. So what that means is this bulb has its very own source or pathway of electricity flowing, and this bulb has its own pathway. So in parallel circuits, everything has their own path. You have more than one path of electricity, and that's the reason that the light bulbs are able to stay lit. Because if I was to cause a break in this light bulb circuit, this light bulb would actually still have a complete path, so it would be able to stay lit. So I'm going to draw my final wire. So click my scribble tool, start at your battery, and click and drag to draw your wires. Going through the third light bulb and back down, all the way back to the battery. So now I have all three pathways. So this is a parallel circuit. A parallel circuit just means that you have multiple light bulbs, and each light bulb has its own path, or just that there are at least multiple paths of electricity instead of just one. Here, there's just one pathway. Here's one path, two paths, so that's two different paths, and then a third path. So the electricity can flow through all three of these. A parallel circuit is basically like if you combined a bunch of basic circuits into one and made them share a battery. Now let's look at a series circuit. So a series circuit is similar to a parallel because they both include multiple light bulbs. But in a series circuit, there's only one path. In a parallel, we have a bunch of different paths, but in series, we have only one. So a series circuit is a circuit in which the current flows through each component, such as a light bulb, one after the other. So I'm going to show you what that looks like, one after the other. If one light goes out, So basically what I really want you to remember about series circuits is that there's one path, and because they are all sharing that one path, if one light goes out, the others go out also. And I'm going to show you why. So we're going to use our scribble tool again. And now I've got it up here, so I just have to click it. And so I'm going to start up my battery. And now I'm going to click and hold down my mouse to draw the wire. I'm going to go through the switch. And now I'm going through all 3 light bulbs at one time. And back down to the battery. And that's it. So you'll notice, again, there's only one path here. Whereas the parallel has 3 different paths that you can identify. There's only one path here. So there's only one place for the electricity to travel through. Now, remember, these light bulbs are acting as conductors as well because they're coated in that metal material. And so they're responsible, they light up, but they are also conducting and allowing that electrical current to flow through to the next item. So in a series circuit, the components or the light bulbs kind of work like a team. If one bulb goes out, if there is a break somewhere in the circuit, or if one bulb goes out, they're all going to go out. Because if this light bulb goes out, that means that there's going to be a gap in the circuit. There's not going to be anything there to conduct the electricity further on. So in a series circuit, you have one path, and if one light bulb goes out, they all go out. In a parallel circuit, you have 3 different paths, and if one goes out, the others can stay lit. And that is it for your notes today.